So going over our 27 essentials and going over questions, we talked about logistics. If you missed the logistics or if you're absent today, just text a friend and be like, hey, what's up? What are we doing? I believe, got around here. Did we keep on going to the next? Yeah, implicit differentiation. One of your classmates at the very end of yesterday said, I don't get it. And I said, you don't get what? I don't get this section. Implicit differentiation, taking the derivatives of functions with x's and y's mixed up. How many of these questions were that? Oh, that's awkward. Can you guys go ahead and change the topic of this to implicit differentiation / differential equations? They totally went in a different direction. / differential equations. Because right here is different. And I was like, okay, well, it's implicitly defined stuff. Because this x's and y's are mixed up. This x's and y's are mixed up. However, are x's and y's mixed up here? So even that, Thomas, that was a good idea, but that only worked for number 63. Shoop, 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 shoop. Yeah, the rest of that is good. Okay, sorry. I just wanted to make that quick correction. But do you guys have any questions on this page having to do with the topics of implicit differentiation, / differential equations, indefinite integrals, or Riemann sums? AJ? 74, right here at the bottom. Use a trapezoidal Riemann sum with 3 subdivisions. Ooh, they're not letting us make them even. But that's okay, because what do we know about as soon as we see trapezoid? Come on, guys. Forever card, what do we know about trapezoids? There we go. So what are we doing? We're trying to find the area under this guy with that guy. Here's what I would do if I were you. I would go ahead and do this like a f of x thing, because the AP would probably give this to you in a table. It's kind of messy the way they did it with words, but that's okay. We have to go from 0 to 6. And what did they say about the lengths? Or you could replace that with the bases. What's the first jump supposed to be? 2. And then the next jump is supposed to be 3. And then the last jump is supposed to be, do you see what I did? The table would have a jump of 2, a jump of 3, and a jump of 1. Jump meaning delta x's, because remember, with all of our areas, aren't the bases delta x's and aren't the heights f of x values? We could do f of xc, I suppose, f of x1, f of x2, f of x3. But how do we get f of x's? Who are we trying to find the area under? That guy. So why don't we just plug in 0? If we plug in 0, isn't it 0? And if we plug in 2, isn't that going to be negative 4 plus 12 is 8? And if we plug in 5, isn't that going to be negative 25 plus 30, which is 5? And then if we plug in 6, negative 36 plus 36 is 0. Does that sound good? Check my mental math. I did it fast and my head is fuzzy. Is that okay? So now, AJ, what do you think? What should we do? Oh, negative 25 plus 30. I think that's 5.
Oh, no, like as in variables too.
Yeah, your jump of 2, your jump of 3, and your jump of 1. So 0 plus 2, 2 plus 3, 5 plus 1. And do you see where I got the 0 and 6 from, just from the bounds? Okay. So now why am I going to go over here and do, well, this is the way I do it. I know some of you guys have a shortened way of doing it, but what am I trying to show you? How many trapezoids? So each of them are going to have 1/2, which is why at the very end we could go ahead and do a big old 1/2 in front. But then sometimes we get to say, oh, all their bases are the same, but we didn't do it. We had to use what they gave us, so are all of their bases the same? Nope, I have 2, I have 3, and I have 1 like they told me. So can I pull out a common base? Nope. And I didn't leave room because nothing's in common. What are my 2 heights for my first trapezoid? If you guys need to, you could totally graph this. The problem is just don't connect. Please don't connect. 0, 2, 5, 6. I don't know. Close. We could graph 0, 0 as a point. We could graph 2, 8 as a point. We could graph 5, 5 as a point. But am I allowed to connect this in any sort of continuous fashion? No, I have no clue what's going on in between those points. But if I'm doing trapezoids, my first trapezoid is going to use what to its heights? 0 and 2. So why not just say, oh, what is f of 0? What is f of 2? Don't I know what it is? Isn't it 0 and 8? The next one, the next trapezoid, would use these two guys, right, to connect? I know that one's going to be a triangle, but whatever. We still just follow the trapezoid rule because that's not always true. This one's going to be a trapezoid. I use 2 and 5, but what are the heights at 2 and 5? This one I'm going to use 5 and 6, and what are the heights at 5 and 6? It's as easy as that. If this was a stick it to the man kind of answer, you could go ahead and just write all these with pluses in between, and you're done. Eurus?
Why do you don't take integral and function first and then
Because this is a Riemann sum, Eurus, and we are approximating area. If you integrate, you're finding the exact area, so you're wrong. Does that make sense? So integral is exact, but no, they say we approximate. Yeah. And the sad thing is that this is a multiple choice. You better bet the integral answer would be 1. That's wrong. It's very sad. So then we go ahead, and 2 times 8 would be 16. And then we have 13 times 3. I'm going to be lazy and just write it. And then we have 5 times 1. And then we can box it and be done. When you go to the answer key, it'll be all nice and simplified. Or maybe it won't. And either way, you should be able to make it match. Anything else on this page up through 74? 70? Ooh, thank you, Eurus. This is an impossible problem. I need you guys to change this. If we were to start solving, some of you might have tried, some of you might not have. You should have made u your cotangent of x. And if you made u your cotangent of x, guys, what's the derivative of cotangent? Negative cosecant squared, isn't it? So then if we were to do our little u sub, eventually we would end up with a cotangent of x times e to the u times du all over with a negative out in front, cosecant of x. Only one cosecant would cancel, and you'd have somebody else chilling. Now you could do some trig and make him cosine over sine and him 1 over sine. You would eventually end up to, even with some manipulation, negative cosine of x e to the u du. Here's the hard thing. You need CalcBC, integration by parts, something we crossed out on our cheat sheet to solve this. And even then, it's a hard one. So we're going to make this a CalcAB problem. And a CalcAB problem would make the following change. You ready? It would cross this out, and it would put cosecant squared. We're going to make it a CalcAB problem instead of a CalcBC problem, and a hard CalcBC one at that. We're going to make it cosecant squared of x. Now is your u sub going to be a whole lot nicer? So go ahead and change the whole problem. Make sure that you're doing it in like a pen so your brain knows, like, no, this is something Miss D says to do. But thank you, Eurus. Now it's going to be a lot more possible. Now we're moving on to the next page of the fundamental theorem of calculus, properties of definite integrals, and MVT for integration. Anything on this page we need to talk about? Yeah, Patricia. 78. Let me zoom in a little bit. I'm kind of zoomed out, aren't I? 78 gives us clues. Oh, way too high. There we go. 78 gives us clues, and those clues involve the integral from 2 to 5 of some function, g of x, I don't even know who he is, d of x equals 10. Do you guys notice how all the bounds, except for the last one, match? Don't we have something here where we can pull a 7 out of an integral? And theoretically we can substitute, right? That one's pretty easy. This one's a little bit harder, except, guys, isn't there a sum and difference rule for integrals, where we could do 2 to 5 of g of x dx with a quick substitution? That's easy. Plus the integral 2 to 5 of 4 dx. This one we plug in the clue. This one we solve by hand, because the integral of 4, what's the antiderivative of 4? 4x, we could plug in the 5 and plug in the 2, f of b minus f of a. Now what's going on down here? What's happened to my poor little g of x? If you remember pre-cal and algebra 2, what transformation has occurred? To the left. Yeah, opposite what you think. To the left 2. So wait, what was 2 to 5 is now, boop, boop, 0 to 3. If your brain sees it, you can just answer 10. But if your brain doesn't see it, couldn't you also see this as a u? And du is equal to 1 dx. And so this is the integral of g of u du. But would I keep these bounds? No. What do I have to do with u's? You guys are going to do some, or you just did some test corrections, sorry, on chapter, was it 5 where you're doing u sub? Chapter 4b? U bounds. So I do u bounds? What's u of 3? Plug it in 5. U of 0, plug it in 2. Oh my goodness, look, it's 10. Either way. Is that good? Yeah. Anything else we have on this page? Up through numbers 80? Number 80. Yeah, AJ. Wow. My computer doesn't like me today, sorry. Thanks, typo. So I'm not going to solve it right now, but I am going to go ahead and, oh, hold on, you can't see the whole question. I don't know if it's necessarily a typo as it is just a poorly worded question. No, I did not make this packet. I like it, but I didn't make it. I think it's a poorly worded question. If you guys were to show this, you'd have the x-axis, you'd have x equals 4, you'd have square root of x, and you have the region in between. Yeah? Okay. But then it says something about like splitting this into 2 equal areas. What would split this into 2 equal areas? A line. And since they say x, I'm like, okay. What they should have, I believe, what they should have done instead was x equals k. They're asking for what vertical line x equals k. What vertical line will split this region in half? So maybe you have to find the region, cut it in half, and then figure out what bound to make it. Just hints, just hints. But that's what was going on in there. Thanks, AJ. That was a good typo to catch. All right, let's go down to topic number 21 in the 80s. '84. Ooh, fill in the table. What have they given us a graph of? F. Oh. If you guys have your note-taking pen, if I were you, I would make a note. Maybe not a note, I would at least put a star. This is technically called an accumulator function. We haven't talked about it a lot this year. I was waiting until AP review. But this way of defining a function in terms of an integral from 0 or any a to x of f of x dx, and then giving you a graph of f, this is called an accumulator function. And the AP loves to give this. Not every year, but frequently. The accumulator functions. Let's think about this. Okay, if they want g of negative 4, because we need to fill in the table, right? G of negative 4, well, guys, isn't that just x is negative 4? So don't I just put in the x in the x spot? So what would be the integral from 0 to negative 4 of f of x dx? Now, it's kind of gross. Now, I'm just doing one little box. I'm going to do g prime, g double prime, and then let you guys think about it. But if I'm doing the integral from 0 to negative 4, of f of x dx, aren't I going from here backwards? Wait, is there anything weird I'm supposed to think about as I go backwards? It's a positive area, right? It's above the curve, right? But hold on, aren't I going backwards? Don't I have to make that negative going forwards? But since it's geometry, all I have to do is base times height, so that's 4 times 2 is 8, cut in half is 4. So g of negative 4 is negative 4, not because it's the same thing, but because it's a triangle with an area that needs to be made negative since I'm going backwards. Thomas. Yeah. Does it make sense how I put x in the x spot? Okay. And how an integral is really an area. And the area is geometric, so I can actually find it without doing antiderivatives. But since my bounds are 0 to negative 4, Instead of going from a lower a to a higher b, I'm going from a b to an a. My properties of definite integrals say I need to switch that and make it negative. Or just think when you go backwards, the sign flips. And then I did area of a triangle. No, because this is a positive 4 that's been made negative because it's above. Does that make sense? Okay. But if I was to go from 0 forwards, that's positive, and then this is negative. Yeah. G prime of x. Well, to do g prime, don't I have to take a derivative? How do I take a derivative of an integral? Cool kids, from FTC part 2. I should technically make that a t, f of t dt. What's the derivative of any integral from a to x of f of t dt? F of x. What does that mean? So f of negative 4, isn't that just the y value? Negative 4 is 0. F of x is g prime. So how do I find g double prime? Well, guys, if g prime is f, then what would g double prime be? Isn't it the derivative of the prime? And what's the derivative of f? The slope. So I can look at negative 4. What's the slope? What's this line? Okay, cool. So rise over run. Go up 1 over 2. Sweet. 1. So g prime ended up equaling f. G ended up equaling an actual definite integral, an area, and g double prime ended up equaling the slopes. Slopes of f, the y values of f, and then the area under f. It makes you interact with all the different possible variations, which is kind of cool. So then you're just going to have to use that same pattern. Does that make sense? Okay. And so we'll leave off the sketch until we figure out some more of that. Guys, Monday we can go over some questions from the answer key if you've gotten stuck as well. I'm just trying to get you enough to actually do the problems today. Is there anything else in the 80s that you guys want to see? P.S. Pause. If you had a question on 85, what do you notice now? Who is this guy? What's the name I just gave him? He's an accumulator. So then you're going to have to use the same techniques as above. So let's wait off on 85 if you had a question there. I think there was something weird here. Where was it? Lorenzo found a typo, or at least a question that needed more detail. Finding volumes. Yeah, it was under there. Here we go. Number 88. What did they not tell you that you needed to know? Volume by cross sections, you always need to know dx or dy, and you know dx or dy based on when or how they tell you how to slice it. Do you notice that they don't tell you anything about perpendicular to what axis, like how the slices are made? Okay, so let's go ahead and add it in. Quick typo here. I just went ahead with Lorenzo. I was like, okay, this question needs adding to. It needs extra details. So I just went ahead and made it perpendicular to the x-axis. I apologize. That question was missing an important piece of information. Perpendicular to the x-axis. Did you guys see any other? I heard someone else being like, when I said typos, they're like, oh yeah. Was there anything else you guys weren't sure if the question gave you enough information or anything in like the clues, the hints, the formulas? Are we getting to where most of us haven't gotten yet? Yeah. Yeah. This sounds a lot like the one, a lot like the one I just did, that x equals k, just this one didn't say x equals k. No, that's okay. But like how I'd set it up is you could take, for instance, a value of x. I'm going to say x equals k just because the other one did it. And we could say the integral from I need to think about who this guy actually is. Okay, x-axis y equals 0. I'm going to go ahead and do natural bounds or intersections by factoring out an x. So I get x squared plus x minus 6 which will be 0 equals x times x plus 3, x minus 2, which means I have a 0 at 0, negative 3, positive 2. This is a cubic, which has n behaviors, and then it's going to do a loopy-loop. So in general, I can say it's going to be something like this. Now, I bet it goes higher, lower, but what I see bounded by the x-axis and the function. There you go. What's bounded by the x-axis and the function? Hold on, contemplating life for a second. If we include this negative, it's going to be messy. So let's go ahead, and I need you guys to add in here the x-axis and the function for x within negative 3 to 0. We need to just keep it the positive. If we go negative, it's going to be an impossible problem. Okay, yeah, let's just go high nat. Just between negative 3 and 0. So that's going to be the entire area from negative 3 to 0 of my f of x, which is my x cubed plus x squared, minus 6x of my f of x dx. I need to cut that in half. And so I can go ahead and put 1/2 equals, well, somehow I need to get a k in there. I could go ahead and do negative 3 to k of f of x dx. So over here, you're going to get an actual constant as to what the area is, the whole area. You're going to cut it in half, and you're going to set it equal to the integral where you say, hey, when should I stop? At what x value will I have gotten to the halfway? Now, you could probably guess it's probably going to be at the critical number. There are actually a couple different ways of figuring this one out. But Christina, there's at least one way. But add in that negative 3 to 0. All right, I'm just saying on the rest of the packet. Is there anything else in the whole entire rest of the packet you guys want to talk about today? Tomorrow, you're going to play with grading, trying to correct. Monday, you're going to come with questions, knowing what the answers are. Does that make sense? Cool. All right, let's just go ahead and group up. Today,